Alright, today is a quick video over kites, and then there will be a few problems over kites tonight for homework. So a couple theorems about kites, if you want to write them down. This is 8.4 part 2 of kites. The first part was about trapezoids. So 8.25 theorem states if a quadrilateral is a kite, then its diagonals are perpendicular to each other. Okay, so you can go back in your notes and find what the definition of a kite is, but if it becomes a kite, then its diagonals are perpendicular. So the example here is if quadrilateral, remember this isn't a parallelogram anymore, we're not talking about parallelograms, we're going back all the way to quadrilaterals. Because a kite is not a parallelogram, it's just a quadrilateral. So if quadrilateral ABCD is a kite, then AC, so one diagonal, is perpendicular to BD, the other diagonal, so we can make a little note there, put a little perpendicular sign. All right, and that actually means that all of these are 90 degrees, right? You could draw all that out. 8.26 says if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Okay, only one pair. So let's look at this example. If a quadrilateral, if quadrilateral JKLM is a kite and JK is congruent to KL, so those top two are congruent to each other, then that means that angle J is congruent to angle L, so we're going to mark that. Angle J is congruent to angle L. And angle K is not congruent to angle M, because only one pair of opposite angles is congruent. It is not, K is not congruent to angle M. Example 4, if FGHJ is a kite, find measure of angle GFJ. So look at this kite. It gives us that the top angle is 128 and the bottom angle is 72. And then we're being asked, what is this angle? Okay, over here. All right, so note, a kite has exactly one pair of congruent angles. So, since G is not congruent to J, the ones across from each other, then 128 is not the same as 72, then F has to be congruent to H. So I'm going to name these both X, and they have to be congruent, so we can name them the same thing. So we can start writing this out as a statement, reason, proof. Measure of angle F plus measure of angle G plus measure of angle H plus measure of angle J equals all four of those. Remember, it's a quadrilateral. They all add up to 360 degrees. And we're going to say angles of quadrilateral add up to 180 degrees. Okay? And now we can start plugging in what we know. So we know that F is X plus, and then G is 128, and H is also X, and J is 72. And that is substituting in. We get 2X plus 200 equals 360. That is simplify or combine like terms. All right, and then we can get rid of that 200, so it goes 2x equals 160. That's subtract 200, both sides, and x equals 80. And remember, x is a degree, so we can put a degree symbol here. And actually, we're trying to find the measure of GFJ, so we need to write it in that form. Measure, oh sorry, let me finish this. Divide by 2. Okay, so we need to write it in the way they're asking up here. Okay, so measure of angle GFJ equals 80 degrees, because that's the same as x. All right, part B, if WXYZ, so this is a new kite, if it's a kite, find ZY. So we're trying to find this over here. All right, so what we know here is we need to use our second theorem, our first theorem that we learned today. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so I need to use that to my advantage. I'm actually going to draw that down here because we're going to use this side. So I'm going to say that this actually makes this whole thing right here, oh, that was bad, a right triangle. So actually we can use some old information. We have a right triangle, we have 8 and 24. We have 2 out of 3 sides of a right triangle. That means we can use the Pythagorean theorem, because we're trying to find that third side. And remember, it's the 2 legs squared and added together equals the hypotenuse, okay? And the hypotenuse is what we don't know, so actually that's what we're looking for. So we're going to go ahead and write this out. We're going to write PZ squared, that's one side. Oh, sorry, this is P in the middle here, plus PY squared equals ZY squared. And that's the one we're trying to find. That's the one we don't know. So this is Pythagorean theorem. Okay, now we can just plug in things that we know. 8 squared. Remember to use your parentheses in case things are negative, and then when you square them, they become positive. Okay, and then this is the one we still don't know, so that's substitution. Okay, so if you do the math of this side, you're going to get, if you plug it into a calculator, you're going to get 640 on this side. So double check that work, because you guys need to practice using a calculator anyway. Okay, that is simplifying or combining on that left side. And then we can take the, remember, to get rid of a squared, we take the square root right here. Okay, and so ZY equals the positive or negative square root of 640. Remember, you can you need both the positive or negative when you take the square root of something. So we are taking square root of both sides. But since this is a side length, the answer can only be the positive version, okay? So if you want to break this down, this 640, I'm going to break it down. So I know that 640 breaks down easily into 6 and 64 and 10. And then once we've broken everything down into the least possible value, we can start pulling stuff out. So ZY, which is what we're trying to find, equals, so whenever there's a pair, we can pull it out. So there's a pair of 2's, there's another pair of 2's, there's another pair of 2's, and what's left under the square root is 5 times 2, so 10. Okay, so ZY equals 8. 2 times 2 times 2 is 8, square root of 10. And there was no values of like meters and inches given, so that is what we leave it at.